Now this illustration deals with enclosing the same size conductors. And we're going to select a table from C.1 through C13A in the Annex C in the back of the NEC. Now, we're using rigid metal conduit, as you see in the illustration. We have 4 conductors in the Raceway, but only 3 or less is current carrying, so we don't have to derate for 4 more current carrying conductors as required from table 310.15 C as in car 1. Neither do we have to derate for ambient temperature in accordance with table 310.15 B as in boy 1 as required in 310.16 in the NEC. Now, the problem is you see there is a question. What size rigid metal conduit is required to enclose 4 number 6 AWG THWN copper conductors? Now the application of the rule is in step 1, sizing the conduit. We selected rigid metal conduit from table C.8 from the Annex C in the code book. So we have 4 number 6 AWG copper conductors, and a 3/4 inch conduit is what is required, to house 4 number 6s. So that's the answer in the solution. But now the quick calc, we know we have from table 4, chapter 9, 40% fill because we have 2 or more current carrying conductors in the Raceway. So we're reviewing a 3/4 inch and doing a quick calc to see if we could house 4 number 6 conductors in this 3/4 inch conduit. Now, number 6, if we go to our table 5, chapter 9, look at the column that has 100% fill, and we would have 0.220. But now, as table 4 to chapter 9 illustrates, we could have a 40% fill. So 40% of 0.220 divided by basically your 0.0507 would equal 4.339. So with that value of 4.339, we see, yes, 4 number 6 THWN copper conductors could be enclosed and routed in pull through a 3/4 inch conduit as illustrated in this figure 12-21 from Stallcup's Designing Electrical System book, volume 1. Welcome to Hot Topics. We're going to continue from the previous video that we did on a nipple, and we're going to look at a Raceway system. Now, to begin with, you want to find a section that would list all your different wiring methods. So in doing so, let's just go to page 146 in your code book, or make note of that section. It'd be 300.17, informational note, page 146 in your NEC. And then it's right on the right-hand side of page 146 at the bottom, and it talks about the number and size of conductors in a Raceway. And then in the informational note, if you would, just count down about 6 lines, and you'll pick up EMT, which is our Raceway in this illustration, 12-22, I believe it is, and Stallcup's Designing Electrical System book, volume 1. And notice in the illustration, we have a 40% fill, and then, of course, we have 12 number 14s, 4 number 12s, and 4 number 10s. And the insulation on the conductors is THWN. Now, we want to go over next to determine what is a raceway? Now you see in 300.17 in the informational note, you have all your different wiring methods listed there. You just choose what you want. Is it a conduit? Is it tubing? Is it flex? You know, basically, which wiring method are you selecting? Now, to determine a nipple and raceway, you know, we've done that. But let's go over now to page 695 in your code book. Write that section down, or page number 695, and we're going to take a look at note 4 to table 1 to chapter 9. And then you notice note 4, it says a nipple is 24 inches or less in length. So anything over 24 inches becomes a raceway, and it terminates on both ends, usually to pull boxes, junction boxes, panel boards, and different types of enclosures. So we kind of pick that up, and then we want to know how many current carrying conductors that we have there. And the only time the number of current carrying conductors become an issue is when it's a Y system, 277-480 or 120-208. So now if we should now go back to our 310.16 and 310.15, we can pick up these rules. So let's just go over to 310 and take a look at 310.15E, I believe it is. 310.15E, as in ed, and we would find that on page 160. So going over to page 160, left-hand side of your page now, the section to determine when a neutral is considered current carrying is 310.15E as in ed, and it's item number 3. And on a Y system, if you're pulling more than 50% of the neutral current and its harmonics or nonlinear loads involved, and you know, we always use a simple illustration. If you had 100 amps on L1, L2, and L3, and if you had 51 amps or more of harmonics and nonlinear loads, then the neutral's current carrying. But if you had maybe 48 amps, no, because you're not 50% or more, see. So we pick up that rule there. In fact, we pick up the neutral conductor along with 220.61 around page 79 of the code. 310.15E and 220.61, they go together hand in hand when you're dealing, you know, with a neutral. Now, 310.16 is also important here on page 160, right-hand side of the page at the top. And notice this tells you when you have to derate for more than 3 current carrying conductors in a raceway, and when you're routing it through an ambient more than 86 degrees Fahrenheit. Now, usually we use a 10% rule, and say that you were routing 10% of 100 foot, and you took 10% of it, that'd be 10 foot. And if you didn't route it more than 10 foot through an area of 86 degrees Fahrenheit, you're fine. So you say, well, yeah, I've routed 10 feet of it at 100 degrees Fahrenheit, but the rest of were 86 degrees Fahrenheit or less, and you wouldn't have to derate. See, that is a good rule of thumb. Now, that's given to you, see, in the item number 3 here on page 160, right-hand side of the page, section number 310.16.3. Now, this is new. This information was taken, revised from our table 310.16. It's not in that table anymore. They moved it here to give you this information for all the tables, 310.16 through 310.21 that we might want to use there. And see in item 3, wiring is installed in a 30 degrees C or 86 degrees Fahrenheit ambient temperature. And if you get above that, you have to derate, which we'll do that in another video. But right now, we're just calling your attention to it. But notice we do get a 40% fill. So we want to go back to page 695, if you will, please. And let's just fast forward over to page 695 in your NEC book. And then notice that we're considered a nipple if it's 24 inches in length, but if it's over 24, we're Raceway. Then at the very top, the table 1 says at 1 conductor, you're allowed a 53% fill. 2 conductors, 31%. But over 2, you get the 40% fill that we're talking about. And so we can go to page 696, and then notice, counting now from the left-hand side of table 4 at the very top of page 696, notice if we count over to that third column, see where it says over 2 conductors, 40% fill, that we just came and reviewed that in table 1, then notice that is the fill area. But the 100% fill would be the last column in the table. And then notice if you had, say, a 1 inch EMT, that'd be 0.346. But 100% would be 0.864. You take 40% of it, and that's what you come up with. So 40% fill is 0.346. You see that? Now, with that thought in mind, if we have a combination fill, and you can see in the quick count we show you that. That's a 1 inch EMT. We take 40% of the 100% fill from table 4, and we come up with 0.3456, as you see in the table. Now, we take our conductors, number 14, 12, and 10, and we go to table 5. So let's go over and look at our table 5, and what's our insulation on our wire? THWN. So we go over to page 701. Page 701 in the NEC, left-hand side of the page. Let's just drop down to, in the first column, and pick up the third set of insulations, and it's THHN, THWN, and THWN/2, and there we would pick it up. So if you had, say, 4 number 12s, let's just look at number 12, and you slide across, and you see that's 0.0133, as you see in step 1. Number 14 would be 0.0097. Now this is when you have combination fill, and you're going to calculate the size of the Raceway system based upon different size conductors that have been pulled through the Raceway, or you're going to pull through the Raceway. So we get all the cross-sectional areas in step 1 from table 5 in chapter 9 there we just looked at. And then 2, we do the math. We take the number of conductors for each size times the cross-sectional area, and we come up with 0.254 square inch area. Step 3, we're selecting EMT, so we need to house and enclose those conductors with a cross-sectional area of 0.254, and we're selecting a 1 inch EMT that's 0.346. And yes, we see in the quick calc in the illustration that 40% of 100% fill, 0.864, is 0.3456, as we see. So yes, a 1 inch will enclose this combination fill area because we are a Raceway. But now there's one thing you've got to realize. We do have to derate. And you notice if all these conductors were current carrying, and you look at how many that you have 12, and 4 is 16, and 4 is 20. So I would go around page 158 somewhere there in your code book, and we may have to make a little adjustment here, but we'll see about that. And we would actually be on page 160, I believe it is. Go to page 160. Left-hand side of the page, down at the very bottom, then notice if we had 20 conductors in that raceway that was current carrying, 50% we have to derate. Now we're saying everything's fine here. We're not routing this raceway through an ambient to exceed 86 degrees Fahrenheit overall, and we're not derating here for loads or anything. But we're just saying you would have to derate, or you would raise the size of those conductors. Or if you wanted to, you could say, well, I have 12 number 14s, I have 4 number 12s and 4 number 10s. I'll make them all number 10, and then I can go to my table and size it based on them all being the same size. But these are a little off here a little bit in numbers, so you might not want to do that. So this is figuring a combination fill with a number of different size conductors to size your EMT that we're running here when it's a raceway and not a nipple. A nipple, 24 inches in length or less, raceway over 24 inches. And now you have it. That's the difference between a raceway and a nipple. And you can also review our nipple sizing and everything in a previous video if you want to do that. If you haven't, watching these videos as they come available to you. Welcome to Hot Topics. You know, I told you in our previous video that we were going to start a new segment of videos titled What's the Difference? And today now we want to go through this video and discuss what's the difference between a nipple, say a raceway, and a sleeve. Now we're going to be using our figure 12-23 from Stallcup's Designing Electrical System book, Volume 1, and kind of use it as a pattern to work with. And before we really get into this video now, I would like to, if you have your code book handy, and if you want to, you can keep it handy and or keep the sections down, and we'll just kind of go through them. But I would like to start on page 695 of your code book. Page 695, if you'll turn to that page with me. And 695 is a good page number. And we want to look at the note 4, right at the left-hand side of the page, right above table 2, radius of conduit and tubing bends. Now notice note 4. It reads, where conduit or tubing nipples having a maximum length not to exceed 24 inches are installed between boxes, cabinets, and similar enclosures, the nipple shall be permitted to be filled at 60%. Now notice in the illustration we show, say, a raceway there, or a nipple, better say nipple. Notice it's 60% fill. Now, we know we get 60%, but before we look at that particular table, let's go over and review, say, page, I think it's 158. Let's just go to page 158. We may have to adjust a little bit here, you know, but going over to page 158 now in your code book, or keep that reference, then notice on the right-hand side of page, it's 158, excuse me, I gave you a bad page number, I'm sorry, page 158, and on the right-hand side of the page, look at 310.15, and we're looking at C1. And notice C1, I'm going to kind of paraphrase this for the sake of time, but if we're not longer than 24 inches in length and we're a nipple, then we're not restricted to any certain number of conductors before derating. We can have as many conductors as we want in that nipple in the illustration 12-23 there, and have as many conductors in that nipple we want at 60% fill. And then notice if you drop down to 310.15C1 and review little b on the right hand side of the page down at the bottom, then it tells you that these adjustment factors, they do not apply. And you have two sections there. C1 deals with the 24-inch rule, and then so does B deal with the 24-inch rule. So in other words, as long as it is 24 inches or less in length between that service panel and that auxiliary gutter there, you're not considered a raceway. Now, the next thing we want to look at is Table 4 to Chapter 9. And let's try page 659. And again, if I miss that page number, we'll adjust, folks. But let's go to page 696, I believe, and then we'll adjust if we need to. Now, on page 696, let's just say that we had say a EMT nipple there, and let's just say, for example, it was a 1-inch. Now look at your table 4 on page 696 at the very top of the page, and look at the 1-inch trade size conduit and slide across, and for a 60% fill, notice you get 0.519. Now if you slide right on across, 100% fill for that 1-inch raceway is 0.864. Take 60% of that, and then you're going to come up with a 60% fill to 0.519. And if you had 1.5 inches, it would be the same procedure. You get your 60%, but instead of like the old days, us having to know to take 60% fill, it's automatically given to you in the table, see? And always the right-hand column will give you the 100% fill in the table. Now that'd be for EMT, and you just go through here and pick out a table. Say if you had flexible metal conduit, then you just drop down to the third table, Article 348 list there. They give you the same thing, see? So you look, you're reviewing this table, and if you had, say, a raceway, it would be 40% fill, see, that you see in the table. And we'll talk about that is when we get to it. But notice now, we have looked at our table 4. We looked at our section 310.15C1 along with the 24 inch rule that we looked at, and we've also looked at our Note 4 to Table 1 to Chapter 9. We've reviewed all those in detail. Now, notice you don't have to derate now for the number of current carrying conductors. So now, kind of keeping that in mind, we can now go to our figure 12-23 and Stallcup's Electrical Design Book, Volume 1. And notice we have a little problem here. We have, notice, a 60% fill. Now, we've talked about that. We're not, as long as that's 2 foot or less in length, we're not bundling in accordance with our 310.15C1 that we looked at. So, we can bundle up to 2 foot or less conductors or cables, and we don't have to derate, do we? It's when we bundle them over 2 foot and we don't allow space between those cables. And a lot of times, the authority having jurisdiction says, well, if you can take a piece of paper and that paper will go between the cables, that's all right. And some say, no, it's the distance between the cables based upon the width of the cables, that they want to look at. So if you had, I'm just saying this, say you had a quarter-inch cable, and I'm just saying that'd be a quarter C between them, or just the paper that would flow freely between the cables. You have to talk to the authority having jurisdiction on that if you bundle, over 2 foot. But now look, sizing this nipple that we see in the illustration, it says what size EMT nipple is required for 912 AWG conductors, 914 AWG conductors, and 12 number 10 AWG, and 14 number 8. Now see, that's a lot of conductors, and you don't have to derate, going through that nipple. And then if you've seen our previous video on what's the difference between an auxiliary gutter and wireway, we're allowed 30 current carrying conductors in that auxiliary gutter without derating for the number. And we're also allowed to have as many as we want of control circuits and signaling circuits and things like that, those type of conductors, as long as it's just for starting and a motor, and after it starts, you're not using them anymore, just temporarily. But now look, we have to go over to our table 5. So we, again, we'll get in our code book, and we'll go over to our table 5. And when we go over to our table 5, we want to pick up our insulation. Our insulation is THHN. So we would go over to our table 5, and we would look at THHN, and that's on page 701 of your code book. Page 701, reviewing our table 9 for the size conductors and the insulation on such conductors. And dropping down into about the 3rd set of insulation markings to the left-hand side of the page, we pick up THHN, THWN, and THWN/2 type insulations. And for that number 12, 14, and 10, let's just look at the number 12 just to save some time. But when you review the number 12 and slide across to the square inch area that you see there, then we're going to pick up, as you see in the illustration, 0.0133 is a square inch area. Now that's the 3rd column there that we would see where we'd have the square inch area. And we do the same for the rest of those conductors. And then as you see in the illustration, we take the square inch area of each of those conductors times the number, and we come up with a total of 0.9726. And then we would go to table 4 to chapter 9. So we go back to the beginning, and we would be basically on page 696, and we're looking at 0.976 there, isn't it? 0.9726. So we know we have a 60% fill, so we come down to a total of that would give us 60% of that. So you'd say, well, what about in step 3, I have 1.5 inches. So you'd come here and look at your 1.5 inches now, very top table on page 696, and you slide across to your 60% fill, and that's 1.221. You see that? And that's what you get in step 4, isn't it? See, in step 3, we're told to take 60% of the 100%. And when we take step 3 and 4 and put them together, that's what we've done. We've taken 100% fill and taken 60% of it, and we come up with 1.2216. So in step 5, you got to compare. Will 1.2216, is that greater than 0.9726 when we looked at step 2 in our total? It is, so that we could use 1.5 inches nipple there. So what is the difference now? And a nipple and a raceway? A nipple is 24 inches in length or less. and anything over 24 inches were a Raceway, and we're going to review that in our next video here. So watch. Welcome to Hot Topics. We're starting a new series titled What's the Difference? Comments from you folks watching our videos. You requested on some items to go into a little bit more detail for you. And this is one of those items that we want to go into just a little bit more detail, and hopefully this will be helpful to you folks. But we're going to be reviewing our figure 12-24, which comes from Stallcup's electrical design book, or Designing Electrical Systems, Volume 1. Now, in the illustration, you see an auxiliary gutter. And at the very top left-hand side, at the top, you see we get a 20% fill. And we're allowed 30 current carrying conductors without any derating. But we do have to determine what is current carrying. Now, to do that, let's go over to page 160 in your code book if you have it handy, or just remember that it is page 160 that you'll find this, and we will look at 310.15E on the left-hand side of page 160 with the title head Neutral Conductor, and we want to focus on E3, and it basically reads, on a 4-wire, 3-phase Y circuit where the major portion of the load consists of nonlinear loads, harmonic currents are present in the neutral conductor. The neutral conductor shall therefore be considered a current carrying conductor. Now we know the phases, they are current carrying. We can't get away from that. But the neutral, let's just give an example. Say that you had and we're just saying this, 100 amps on L1, 100 amps on L2, and 100 amps on L3. Well, 50% or more of the current on that neutral is related to harmonics or nonlinear loads. So say you had 51 amps, the neutral's current carrying. Say you had 49 amps, then the neutral is not current carrying by 310.15E that we are reviewing here. Now, when we go back to our page 229, you'd pick up metal raceway wireways, and we don't want to do that. We want to go back over and pick up 366, and we want to determine what is considered a auxiliary gutter or wireway. Now, reviewing the auxiliary gutter, you see the sub-panel disconnect there. If that wireway extends over 30 foot from the edge of that sub-panel disconnect, you become a wireway then, and you have to install and use the Article 377 instead of Article 366. And basically that's what the code is telling us. And a lot of people say, well, where is that in the code? Some folks just don't know where that's located if they haven't had experience in designing auxiliary gutters or wireways. So we want to look at 366.12, item number 2, on page 223, Article 366, and let's go with it here. Item number 2. But first of all, I guess it probably would be better just let's look at 366.12, uses not permitted, the title head. And it basically states auxiliary gutters shall not be used to enclose switches, overcurrent devices, appliances, or other similar equipment. And then 2, to extend a greater distance than 30 foot beyond the equipment that it supplements, which we just pointed out. And then you have an exception that says, no, this is not true for elevators. It could extend further than 30 foot, say for elevators. Now, we drop down then to 366.22 on the same page, 223, 366.22a. And if we read that down about into the fourth line, you get your 20% fill. And notice if that's for a metal auxiliary gutter. For a non-metallic auxiliary gutter, it's the same thing, 20% fill. But notice you have to derate for current carrying conductors in an auxiliary gutter that's non-metallic, but not metal, because the metal will absorb, see, the heat that those conductors will create when loaded. Now, notice 366.23 refers you in the fourth line down to 310.15e for your considering what is current carrying, like 30 current carrying conductors. And then if you read on in it into the right below where it says in the fourth line down, 310.15e exceeds 30 at any cross-sectional area, then notice the next sentence. Conductors for signaling circuits or control circuits between a motor and a starter used only for starting duty shall not be considered current carrying. So you could have 30 current carrying conductors in an auxiliary gutter, no derate. And we're just saying this, you could have 30 control circuits or signaling circuits just for starting. You'd only have, although it would be 60 conductors, you would only have 30 that was current carrying, so there'd be no derate, but you'd still be stuck to that 20% fill, see. And then if you wanted to size say a bus bar, say you wanted to put a bus bar in your auxiliary gutter, and you had 3 of them in there in this case, and you could have L1 terminating, L2 and L3, but you'd have lugs. And you could just take an Allen wrench, and loosen the lug, remove the conductors, add conductors, a smaller, larger, whatever, see, and maybe set a different size disconnect and so forth. And you wouldn't be taping the connection that you see, where you see three 250 kcml conductors, and we're just using a one-line diagram for simplicity's sake, make it simple. But notice we have a ball there when we make our connections, because we tape it with friction tape, and then we put Scotch 33 over it, usually how we used to make those, see, with a kearney listed for more than 2 conductors, and we used to purchase those for that. And sometimes we didn't, but that would be a violation naturally. So we see what that is, and then notice we're tapping with the conduit to that sub-panel disconnect and 2 foot or less, so that is considered a nipple by note 4 to table 1 to chapter 9 on about page 705 of your code book. So we don't have to derate there, so we're pretty well in good shape, right now. But now notice the supply conduit coming in is a feeder. It's over 2 foot long. So you got a derate if you have more than 3 current carrying conductors. You're allowed a 40% fill in that Raceway. But in that nipple that you see connected to the auxiliary gutter to the sub-panel disconnect, if that's 2 foot or less in length, that's a nipple, and you get a 60% fill, and you don't have to derate, see. But now one of the other things is, that's important here, if you have this auxiliary gutter extending more than 30 foot beyond this last supplemented device, such as your sub-panel disconnect, you become a wireway. Now, you couldn't put that bus bar in there uninsulated like you could if it's an auxiliary gutter. Now, notice we find that information on page 223 of your code book, or just remember the section number, 366.56. And where you make that splice, where you got the little dot and you're splicing those conductors together, you get a 75% fill area just there where that splice is by 366.56a. And that goes into more detail also in our electrical design book, volume 1. Now notice B, as in boy, bare conductors. So you can tap from bare conductors, but that would be those conductors like that bus bar that you size and 366.23. For example, say that you had a quarter inch thick bus bar and it was copper, then that'd be a quarter times 1,000. That's how many amps you could put on it, see? Link wouldn't have any difference. If it was half inch, then you could take a half inch by 4 times 1,000, as you see listed and the permission given in 366.23a. If it's aluminum, then if you read into the paragraph, it's only 700 amps. So it'd be a quarter times 4 times 700. And that's how many amps you could put on that bus bar. That's when we would size, say, our bus bar. And that's what it's telling you in 366.56 on these bare conductors. And it tells you taps from bare conductors shall have the gutter opposite their terminal connection in conductors and shall not be brought in contact with uninsulated current carrying parts of different voltages, see. But it does say that we can use those bus bars there, see, and really that's what that's saying to us. And if we wanted to go over now and look at 376, go over to page 229, or kind of mark that down. And on the right-hand side of page 229, down at the bottom, we pick up 376.56, title head, splices, taps, and power distribution blocks. And then notice, to save a little time here, we'll go to page 230 on the left-hand side of the page and drop down to item number 4 under B as in boy, title head, power distribution blocks, and we pick up live parts. Now notice what it says. Power distribution blocks shall not have uninsulated live parts exposed within a wireway, whether or not the wireway is covered and installed with a cover, see. And then it tells you about the conductors. They have to be insulated. So you lose that benefit. But there's you need to read your Article 366 if it's an auxiliary gutter. Compare it to Article 376 for a wireway. And you'll see that's one of the main differences in an auxiliary gutter and a wireway. But you got to read those two so that you pick up the differences, but that's the main difference. Now, if you look at this, we have 3 250 kcm conductors coming in, and we're tapping with 3 1/0 and 3 4/0. So going over and looking at step 1 for a calculation, 250 kc mil from table 5 to chapter 9 has a cross-sectional area in the right-hand side, last column of the table, 0.397 square inch. A 4/0 THHN is 0.3237. A 1/0 THHN is 0.1855. Now, step 2, we're going to perform the math. We have 3 of the 250, so when we do the math, it's 1.191. We have 3 4/0, so when we do the math, it's 0.9711. We have 3 1/0, so when we do the math, it's 0.5565. When we total, we come up with 2.7186 is our calculation. Step 3, then if we want to take the square inch area that we just calculated in step 2, which is 2.7186, we divide that by the 20% fill, we come up with 13.593 square inch area. So in step 4, we do a little comparing. We say, well, we got 13.593 square inch area. Would a 16 square inch fill gutter do it? So we take a 4x4 gutter times 4 times 4, we come up with 16 square inch area fill. Yes, it will house it, so the solution would be a 4x4. But now we can do some quick calcs. If you look at the illustration, the quick calc 1, with a 4x4 auxiliary gutter, 16 square inch area fill allowed to be used, and that would be times 20%, we come up with 3.2. 3.2 square inch area is greater than the calculated load in step 2 in the calculation, which was 2.7186. So we know in quick calc 1, yeah, that 4x4 auxiliary gutter works. And then when we do the quick calc 2, we take 100, divide it by 20%, get the reciprocal of that number 5. 5 times the calculated area in step 2. We take 2.7186 times 5, we come up with 13.593, and a 4x4 is 16, so yes, it will house it. So either one of these methods could be used, and you're right in tune with the requirements of Article 366 as well now as Article 376 for Wireway. The only difference is that you have to follow the requirements for Wireway and Article 376 and follow the requirements for an auxiliary gutter and Article 366. So that's the difference in and the differences in a Wireway or auxiliary gutter. I hope you've enjoyed this video, and by the way, I'd like to remind you, if you like our videos and they're helpful to you, well, subscribe, be a member of our channel, and these videos will come to you. And again, we're starting this series, What is the Difference? And we're going to call out certain things that electricians do every day out in the field, and we'll use a lot of these quick calc methods along then with the actual code requirements. So good luck in designing an auxiliary gutter and a Wireway.